In this video, we'll find the distance between a point and a plane. Now first, let's see what the general formula is, and then we'll just plug in these numbers to get the answer at the end. So, we have some random plane and some point P which is not on the plane. And what we want is this distance, which I'll call D. So we want the length of this segment, which goes from P and meets the plane orthogonally, so that this is a right angle. Now to figure out what this distance is, we need some other point on the plane. So any point will do. So we randomly choose some other point, which I'll just call R, which is on the plane. And now what we can do is we can draw a right triangle here and use some trigonometry. So let's connect the point R with the point where this dotted line meets the plane, and then complete this right triangle, draw the hypotenuse, which is the vector RP. We also have the normal vector to the plane, which I'll write as little n. And if you take this right triangle that we drew and flip it over the diagonal, over the hypotenuse, you'll see another right triangle, like this. So this right triangle that I just drew is really the same as the first triangle, just sort of flipped upside down. They have the same hypotenuse, but one is just the reflection of the other. But what we see from that is that this distance here is also D, the number that we want to find. Which sort of makes it easier, because if you look at it just right, you'll see that, well, let me draw it in a different color. Maybe let's draw it in blue. This vector right here, in blue, is exactly the projection of the vector RP onto the direction of n. So, what that means is that D is just the length of the projection of RP onto the direction n. And if you'll think back to when you learned about the dot product, there's a formula for this, for the length of the projection of one vector onto another direction. And it's given by taking their dot product and dividing by the length of the one being projected onto. So the direction vector, in this case n. And this dot product might be negative, so we need to take absolute values. And that's it. So this is the formula for the distance between a point and a plane. So just to recap, you take some random point R on the plane, and then take the vector that points from that to your original point P, and project that onto the normal direction. And the length of that projection will be the answer, will be the distance between the point and the plane. Okay, so now that we have the general formula, let's just plug everything in for our example here. So here, from the equation for the plane, we can just read off the coefficients. So n is 1, 2, 5. And from the formula above, you see we need its length, which we can see here is the square root of 30. We were given the point P already. It's 1, 2, 4. And R, we can choose whatever you want, as long as it's on the plane. So pick any x, y, z point that satisfies this equation that we were given at the beginning. That x plus 2y plus 5z should be equal to negative 2. I'm going to pick the point 0, negative 1, 0. But you could pick something else too. Okay, so in this case, for the r that I picked, the vector rp is going to be 1, 3, 4. Now to finish up, just use the formula that we have above. We need to take the dot product of this with n. So 1 times 1 plus 2 times 3 plus 4 times 5, which should be 27. And the length of n we already computed was square root of 30. And there we have it. We're done. This is the length of the segment from the point P to the plane that meets the plane orthogonally.